For this lesson, I'd like to look at graphing equations. The equation that we're looking at is x plus y is equal to 5. So let me jot that down here. A good standard approach to sketching the graph of some relation, we call it a relation because we are relating x and y, this time in an equation. A good approach is to solve for y. It's pretty easy to do here. I can subtract x from both sides. I get y is equal to negative x plus 5. I can then create a table of values where I choose some things for x, figure out their corresponding y's, and then plot those points. I think I'll maybe just pick a few here, maybe going from negative 3 down to 0, then to positive 3. Okay, like this. All right, so if I start at negative 3, maybe I'll do this one out. I take that value, I put it in place of x, and then simplify this down to one number. That's positive 3 plus 5. This gives me a y value of 8. So there you go. At negative 3, we get 8. I'll draw that on my graph. So negative 3, positive 8 is that point. If you are careful here and you list these out, you'll see you get 7, 6, clearly at 0, you're going to get 5, and then 4, 3, and 2. They seem to be decreasing by 1 every single time. So that corresponds to negative 2, 7, negative 1, 6, 0, 5, 1, 4, 2, 3, 3, 2. And I mean, once you have enough points up here, you can just like draw a conclusion where I think this is a line and it's going through the points on my graph. So I'll just draw a line going through those. So just a basic sketch, enough points to get an idea of what the whole equation is going to look like. So from here, the other questions are, well, what's the domain and range? And then do we think that this relation is also a function? So in terms of the domain and the range, this is going to be a little bit different than what we saw last week because, well, this thing is increasing in if I go in this direction, the graph is increasing forever. Heading in this direction, it's decreasing forever. That must mean we're getting every single x value back and every single y value back. That is the domain. It's all real numbers. It's everything from negative infinity to positive infinity. This graph, like let's say you started at 0, the graph is moving to the left and it never ends. It's also doing the same thing as we go to the right. This thing never stops. And the same is true for the y values. This graph is moving up, and then over in this direction, it's dropping down. You get every y value back as well. So the range is all real numbers. Now, is this a function? And the answer to that, so is this a function? The answer is yes. I can see this from the graph as well. No matter what x value you choose, you only ever get one y value back. You can see it from the equation, but you can see it from the table of values too. When you put negative 3 in place of x, we got 8. It's impossible to get a second value, and it doesn't matter what you're choosing for x, you're only ever going to get one value back for y. So you can use the graph, but you can use the equation as well. So here's a standard way to sketch the graph and then determine the domain and range and whether or not it is a function. For example 2, I want to take the same approach where I give you a relation and then we just try to sketch this graph and to determine the domain and range, and if it's also a function. This one's a little bit different because it has y is equal to 4. There are no x's that appear anywhere, but that's okay. I mean, this is still a relation. It's just x is not involved in the expression itself. And actually, in terms of our approach in the last example, to solve this thing for y, you don't have to do anything. Y equals 4 is already set up for us. So if we look at a table of values, x, y, and maybe I'll use the same ones, negative 3, negative 2, negative 1, 0, 1, 2, and 3. The question is, what do you get back for y for these particular x values? So I'll choose 1. I'm going to say, well, what happens for x is equal to negative 3? If you look at your equation, y is equal to 4, you'd have to put negative 3 in place of x. but there are no x's. In fact, that's it. The answer is just y is equal to 4. So for x equals -3, y is equal to 4 must be the answer. So there's nothing special about -3. It's true for any value. So it's equal to 4 at -2 and at -1. And in fact, for any x value that you pick, you always get 4 back. So if we go to graph this thing, at -3, you get 4. Same thing happens at -2, -1, 0. Also at 1, 2, and 3. And in fact, at -5 or -10, +10, it's always 4. If you look at this graph, it's a line. It just happens to be a horizontal line that extends forever to the left and to the right. So it's a strange relation, but it does have meaning, even though there are no x's in it. What will be different is, well, what about the domain and the range? For the domain, the graph goes to the left forever and to the right forever, so it's got to be all real numbers. In fact, if you even look at the table, you're allowed to put any number you want in place of x, because it works. You always get something back for y. But the range is not going to be all real numbers here. The range is actually just one number, 4, and nothing else. Like, for example, is 10 in the range of this function? And the answer is no. If you look left or right, the graph does not exist. It's stuck at y is equal to 4, which is why that's the only number you get back. And is this a function? And the answer to that is also yes. Every x value that you choose, like -3 or -2, it only gives you one y value back. Or if you look at the graph, like at -3, I can see there's this one value here, but there's never something above it or below it. So it's definitely a function. I know the domain and range, and this is a sketch of the graph. And for the last example, again, another relation, but this one's just slightly different. It's almost identical to example 2, but it's not just y is equal to 4, it's the absolute value of y is equal to 4. And just maybe a quick reminder of absolute value. So what is that? If I say the absolute value of a number, like maybe the absolute value of -3, it takes a negative number and makes it positive. But if a number is already positive, like maybe 7, well, it just gives you that number back. So absolute value makes negative things positive and leaves positive values alone. So what is that going to do for this particular relation? What is the graph going to look like? So this one's weird because you can't really solve it for y. So we're going to have to come up with some other strategy when trying to plot what this graph looks like. And I think the best approach here is going to be to just, we're going to guess. We're going to guess points. So we're just going to think about x and y values that make this a true statement. So I'm going to start with a guess that's wrong. But from that, I think we can reason out all of the numbers that will work. So here's my guess. I'm going to say, I don't know. I'm going to look at the point 5, 5 and ask myself if it makes this a true statement. The answer should be no, but let's try it out. So 5, 5. That's x is equal to 5 and y is equal to 5. To see if it works in the relation, well, x equals 5 doesn't go anywhere because there are no x's, but I'll put 5 in place of y and ask myself, well, does it make the relation true? Clearly not. I mean, 5 is not equal to 4, so no. This point does not work. But from this one example, I see the error that I made. If I put a 4 here, that means I place a 4 here, and clearly that's going to be a true statement. So I'm going to try, maybe I'll try 5, 4. Does this work? And the answer is yes. That's because you take 4, you put it into the absolute value. Does it give you a true statement? And well, it does, because 4 is equal to 4. This is great. This means 5, 4 works, so I'll plot that point. If you think about it a little bit more, there was nothing special about me choosing 5. In fact, you can put any number you want in place of x, provided that you put 4 in place of y, because you always get the same thing. The x doesn't go anywhere, but 4 goes in place of y, and you get a true statement. This means that 0, 4 has to work, or -5, 4, or 10, 4, -10, 4. All of those numbers work. So you get this horizontal line at 4. Now, there are more points that work, and this is due to absolute value. So I'm going to pick another one that I think works too. So instead of 4, had I put -4 into the absolute value, you would still end up with this true statement. So let's look at one in particular. Like, how about 5, -4? Does this work in my relation? And the answer is, again, yes, because the 5 doesn't go anywhere. The -4 goes in place of y. This is 4 is equal to 4, a true statement. So you can plot the point 5, -4. And again, the 5 was not special. As long as you put -4 in place of y, the x value could be anything. So it could have been 0, -4, -5, -4, 10, -4, and -10, 4. For all these points, you get a horizontal line, but this time it's at -4. So this is the entire picture of what the relation looks like. So for this here, I think I'm going to start with, well, is this a function? And okay, this time, no. The answer is it is not. If you look at any x value, like here, -5, you get 2 y values back. I mean, that's enough to say that this thing is not a function. Now for the domain and the range, the domain is going to be all real numbers. You can put anything you want in place of x. But not only for the range are you going to get 4, you get -4 as well. So the domain is all real numbers. The range isn't just 4, it's also -4. And that is it for this example.